Good afternoon, good morning, good evening. Welcome to EIG's 37th webinar Fireside Chat on new product introduction, generating speed through digitalization. And our Fireside Chat discussion will feature our guest expert, Paul Reynolds. We're going to put him on the spot from Acoustic, who lives in Seattle. We appreciate that you taking the time to join us on this group and series of webinars. Our first webinar was focused on building the foundation, second webinar on rational risk-taking, the third webinar on digitalization, which we're revisiting today, and our fourth webinar was focused on accelerating new product introduction and agile sprints aligned with phase gate discipline. And that was on our last webinar, Fireside Chat. We actually had some discussions on that. Again, we look forward for your participation in the webinar. If you could answer the polling question, join us in the polling at pollev.com, Jim DeVries 073. That'd be wonderful. It's sometimes easier to do it on your cell phone than it is opening another screen. It's up to you. My name is Jim DeVries, president of Enhanced International Group. EIG is a platform of 40 or 50 consultants, consulting companies, and SaaS providers dedicated to empowering your organization's workforce to expand and sustain your organization. Our goal is to provide collective, experienced thought leadership to enable organizations to deliver that differentiating difference and bringing it to your bottom line in the form of margin, not just top line growth or cost out, but margin. And our partners work to provide you the 1 + 1 + 1 = infinity to your bottom line. We hope that you find that the information is useful for you and your teams, and we welcome questions and dialogue throughout this webinar. So please have your cell phone handy or your second screen, but also when we have the Q&A, which is going to be just about every slide, feel free to raise your hand or ask Q&A for every question. This is a fireside chat, which means everybody is part of the discussion. We are organized under people, process, data, and technology, and we're focusing on process here with new product introduction and digitization. And so we're really combining process and technology and data in this discussion. So we're really trying to look at it from, of course, a people, process, data, technology, but focusing more on process and the importance of data through digitization and the technology to get us there. Our next webinar next week will be on digital twins, and we'll be doing a demo on July the 20th. On the 22nd, we'll be looking at de-risking of large-scale projects, focus on new product introduction. So a week from today, we'll be back here talking about NPI again. And on the 27th, we'll be looking at supply chain risk management. And then on the 28th, we'll be having a very interesting discussion that you might find interesting is the trade-offs between leaning out of supply chain and supply chain risk management. There's trade-offs there. So that'll be a fireside chat next week on Wednesday. So that'll be pretty fun. And then in the fall, we'll regroup. Obviously in August, everybody's going to be out having a good time. So we're very fortunate to have with us Mark and Phil. So I'll ask Phil first to introduce himself. Phil?
I'm Phil Samuel. I am fortunate to have worked on lots of new product introduction, spent most of my career, everything from developing aircraft engines to ERP systems to software to a variety of stuff. I've done lots of work in the front end of innovation where we focus on customer needs and coming up with the right concept. The back end of innovation where we spend most of the time in perfecting designs, perfecting design for X mindset. Glad to be with you.
Thank you, Phil. And Mark?
Hi, Hi, I'm Mark Sneeringer. A lot of my career was in engineering organizations, new product introduction. Later in my career, got heavily involved in continuous improvement across the entire enterprise, and have been actually working with companies over the last 5 to 6 years, doing things to improve their processes, most of that work on new product introduction.
So very esteemed guest here. And to top it off, we have Paul Reynolds from Acoustic. Paul, a few words.
Thank you. So my career has heavily been in new product introduction. For over 10 years, I led a finite element simulation company, which ended up being the premier choice for the ultrasound industry, sonar, non-destructive testing, medical imaging, and therapy. So I worked off a very large number of NPI projects in a number of areas, as well as the software. So a fair amount of experience both developing the products and developing the tools, the digital tools, to speed up and improve NPI.
So Paul's not only performed NPI, but he's performed NPI in yourself, right? Because you created your own company. So very impressive. So we got a twofer here. Thanks, Paul.
You're welcome.
And so again, please do join the poll EV, and so that you can participate in the polling. The next polling question will come up in a few minutes. We really need your responses too, so we can guide this webinar talk. So just as a background, our webinars this is a series of webinars. The first was building the foundation, 2 was rational risk taking, 3 is digitization, and 4 is agile sprints. And we've had 2 fireside chats on this being the second of the 2. Again, we will be focused on digitization on this and the tools to manage and accelerate the development. So with that, Mark, a few words, kick us off.
You know, part of the there's a need for speed in innovation, and the pandemic has actually impacted that as well. So generations of products are getting shorter and shorter, so that the cycle time of replenishing them is getting shorter and shorter. But in the pandemic, we ran into some issues that impact that speed. So reduced opportunities to interact with the customer, a lot less face-to-face collaboration, and being in the lab doing experimentation and stuff. And then it also upset the supply chains in terms of working with suppliers to get early and to get what you need in the into your new designs. So these sort of had a real impact on it. What we've tried to do over the last few webinars is to talk about how can you get some of that speed back that the pandemic has presented these challenges.
So if you have questions or comments on how you've seen this in your business, we would appreciate your thoughts. Either write or raise your hand, and we'll allow you to speak on here. But we're really looking at, what are some of the common challenges you have? We've listed a few here, but are always open to your feedback here on this. Paul, do you have any thoughts on this and what you've seen from your perspective?
Recently, actually, the digitization has been less of the issue, as basically supply chain is probably one of the biggest ones for I can say companies I've been working with, whether it be weather actually affecting chemical supplies or shipping containers or semiconductor demands. And that has actually, on the one hand, it has caused initially problems in that's where the focus went. And I've actually started to see focus going back to digitization, because it's like, well, we can't actually build things right now. What can we do at least to be moving forward with? So I think that there's 2 aspects to it, and the supply chain issues right now are going to keep rippling through for some time.
So I'm going to build on that on the next slide, but again, folks, please do, chime in at any time. But, this slide was put together because of exactly what Paul said, is we have a lack of supply and changing demand. For instance, in the chips, obviously, that everybody's been talking about, but there's many areas where we're having this supply demand imbalance because we were very lean in the past. And having that digitization capability greatly enhances the ability to innovate. So with the pandemic and a lot of cyber types of activities and all sorts of risks that are out there that we focus on in supply chain risk and resiliency, or supply chain risk management. As we go through and recover from this recovery, where people have turned it off the spigot in order to save money, and now you turn it on to try to get back, while people are doing other things. Now other rearrangement of priorities have to take place until we can even out demand. And we estimate from a supply chain risk and resiliency perspective, it's going to be at least another year to 18 months before it'll level out. And of course, it also depends on COVID being addressed throughout the world. So right now, the US is back up and running for the most part, but the rest of the world is not. So we are in a global supply chain. We do depend on across the world. So until everything evens out, it's going to be sluggish for the next at least 12 to 18 months, maybe 2 to 3 years, depending on how fast the rest of the world recovers from the pandemic. So I'll leave that open. Any comments on that? On what folks are seeing?
So one question we've got is they're saying that they don't see people on here as much, and there's a lot of businesses are having trouble finding the resources that they need, or the people resources that they need. So I'm seeing that definitely in some of the folks I'm talking to, that you're just not finding, engineers, factory workers, all sorts of people. That's another issue that's causing disruption right now.
Yeah, I'd call that a lagging, right? Because of these disruptions, people are doing other things. They're changing. They said maybe the career that they were looking for in the workforce was not what they wanted to do. They're taking time to reconsider. They've adjusted to the new norm of doing something completely different. So all of a sudden, with everybody changing job roles, you have these holes for some of these very important positions, and they're either off or they're reskilling in another skill that so I'm wondering if from an education perspective, there's a lot of change there right now. From a supply chain perspective, I know that I think the number I heard was we're 50,000 people short in supply chain. There's 50,000 job openings in supply chain.
Well, I can't comment on the supply chain jobs. From what I see from people I'm working with at the highly educated, highly skilled area, it's people have essentially decided that they're not going to put up with the conditions that existed prior, be it pay or toxic work culture. And simply people are just drawing a line and they're not doing it. And if companies want to get people in, they need to offer interesting jobs, competitive pay, conditions where they can work from home or as needed, and a lack of toxic work culture, which is the biggest one. And unfortunately, the problem is often the people who need to fix that last one are the people who are actually the ones causing it. So I think that is also a very long-term issue. And companies who don't fix those issues are simply going to start dying because they're not going to have the people. Company culture is going to matter for the very, very highly educated, highly skilled groups.
Yeah, and you have the retiring of all the baby boomers at the same time as,
Yeah.
so you have a lot of things coming together.
Yeah.
So
Yeah,
people,
I think the pandemic has basically been an impetus for a lot of this reckoning to happen, and I don't think things are going to go back to normal. It's going to shift to a new normal.
yeah,
And so it's in a number of areas around people type things. And so yeah, I think it's an inflection point right now for us with in terms of culture, in terms of environment, that sort of things, work environment. So
great discussion. So I think we'll move on to more into the digitalization area. And we'll start with this overall view of the phase gates of new product introduction, from customer business requirements, conceptual design, preliminary design, detailed design, prototyping, pre-launch, and full launch. So the way we laid this out is on the top half is you see digital process methods on the left, and it identifies all the digitalization types of technology that's really been developing over the last 20 years, and it's starting to hit a crescendo now as far as providing very unique ways of looking at data that we've not looked at before. We're really trying to look at the data end to end, not segmented by a gate or a process, but really tying everything together. So what's the time in the life of a new product introduction, and what was the data that made it up through the transactions, the interactions with each and every person, and technology that stores that information, and how can we get more efficient and effective on that. So it's a different look than the traditional way of looking at digitalization, which is below the phase gates, which is targeted tools and methods, which are still strong and prevalent and just as important as ever. And Paul, of course, having the experience in simulation transfer functional modeling. So we'll certainly ask Paul to comment on what he's seen over the last 10, 20 years and where he sees that going. Then we'll also address digital ethnography with Phil. And we've talked about people and people analytics. Interestingly enough, the workforce is changing, as we just discussed, and the people analytics behind that is going to become more and more important. And then the next topic that we'll discuss is digital trees, biomimicry, expert systems. And if there's any other area here that you would like to discuss, the next polling question will get at that. Anyone have any added comments on this slide before we move on? Okay. So the next polling question, again, if you would type in https://jimdebris073, log in. This polling really requires you to be on a web browser. Can't answer this question on a cell phone with a chat or a text message. So we'd ask you to rank and order these tools, methods that you feel are most important for you, that you would like to discuss today. That would be great if you would log on to the system and force rank what is most important to you and what you want to hear today. If you have any questions about what any of these items are, please let us know. So we have process simulation right now, leading the pack. Which is great. Then we can have Paul stand up and shout out all his great knowledge to us. So Paul, while we're waiting here, while people are responding, what's your elevator speech on process simulation?
Okay, so I spent 10 plus years developing the software and working with customers to use simulation software. We called it virtual prototyping at the time. The goal, you really want to either improve your knowledge or speed up your design cycles. First of all, it's never a full replacement for actually building things. It's a guide, and how much effort you put in determines, is it, well, it's somewhere over there that you want to go, or is it, I want, a detailed map of exactly the turns and waypoints you want to take. I worked with companies who would sit down and immediately expect to get a full 3D model and everything works and it's perfect answers. Doesn't happen like that. The best companies I work with took the time and effort to characterize their materials, characterize their processes, develop test systems that actually got the data by which you could compare and do feedback. So simulation on its own isn't enough. You can't just get it and expect it to work miracles. It's not a magic wand. So what I found simulation did was it actually ties together all the other components. It ties together your measurement. It ties together your supply. It ties to, what's the QA from what's coming in from your suppliers? Is it 5% variable? Is it 20% variable? How does that vary in your products? If you're making 5 products, 5 a year, doesn't matter. If you're making millions, well, that variation can make the difference with 1 product coming back or 1 million products coming back. So all these things actually started to tie together. So some people weren't prepared, some groups were not prepared to put that effort in because it's a global system approach. But simulation really starts to tie together all the other aspects. And I think, so I noticed a question, what are the typical failure mode? Companies that are trying to digitize but fail. It's not a magic wand. You actually need to understand all your other areas, and it may show up weaknesses such as in your processes or your incoming QA for your supply. That these things vary. So that's actually the biggest fail, is it puts a magnifying glass on everything else that you do.
So Paul, how do you start a simulation? Where do you start with all the assumptions and modeling? How do you get started and set a realistic goal and manage those difficult conversations of people possibly believing too much or not enough in the simulation?
So with somebody who's very, very new, what I teach when I give courses is start with the simplest component you have, the simplest layer, the simplest thing that you can test and compare, and simulate that. And if you cannot simulate the simplest thing and get a good match to your measurement, something's wrong. Either you can't measure what you're wanting to look at, or you don't understand your dimensions or your properties, or your modeling's wrong. So start with that. People want to jump in at the bigger end. You've got to start with something small and build up. So when something goes wrong, you know which part it is. And that's part of the time-consuming component of it, is when you first start, it is slow. You've got to build it up. Now, 2 years later, you've got a great suite of everything. You understand everything that works. But obviously, if you spend $50,000 on a simulation package, the boss wants results now. And that is a difference between them. It's not a tool that will get you it quickly. So I always encourage people, assume this is going to take some time. Work with a consultant who can help you get up to speed quickly, and then you can gradually tail off with them as they build tools specific to you. I'm assuming that somebody's dealing with an NPI, something that's unique to them and isn't like just a me too tweak a couple of parameters. But that's really the key thing. Start simple, make sure it matches with reality, and build from there. Don't jump in at the deep end with absolutely everything, because when something goes wrong, what went wrong? You don't know.
Yeah. There's a note in the chat that supports what you're saying from Ron White, saying, yes, for sure. You get out only as much as what the company puts into each simulation, either process or product. that, you know, you've got to put a lot in
Yeah.
to get a lot out.
If you want a result now, pay a consultant who does this and get your result from them. If you want this to be a long-term tool, it's the same as buying a big piece of capital equipment. It takes time to install. It takes time to get it working right. It takes somebody who uses it a lot and maintains it to keep it going. So it should be thought of in many ways more like that. But of course, everybody tries to move that kind of expense from capital to operations because it's just easier to get through. So companies kind of shoot themselves with that kind of approach.
Yep. Okay.
So I have a question for you, Paul. With digitization and having more live data, how common is it to have continuous data feeds into simulation models to help you in your designs? And how is that a common occurrence? And in what types of areas does it work, and what types of areas does it that way?
So I've seen a few, and it's the best companies that are prepared to put the effort in that get the best results. One of the examples I'd give is when a company I worked with, and this was maybe 20 years ago when they first started, for each of their NPIs, they built somewhere on average between 80 and 100 prototypes for their typical line to get to the, okay, this is what we're going to deliver to the customer. Then they spent a couple of years going all the way around, and they got it down to about 10 or 15. And about 4 or 5 years later, they were down in the single digit. Now, you always seem to need to make it, but that was they compared their process. They would slice and do optical images. How does this compare to? They put a lot of effort into it. It was heavy investment up front, and it was right from the process through the testing. All of it went back. Huge investment, but it paid off. Otherwise, it's actually very hard because you've got to, in a large company, you've got to work with a lot of people and get that information in. So usually what I find is it's here and there with what is easy to get and easy to do. And the more you can do, the better, but it's also expensive, and a company can't always do that. So it's really go for the key areas. And one of the things I also push when teaching is, are you going for a qualitative result or a quantitative result? Do you want something that says, if you do the following, it will get 3% better in this regard and 1% worse in this regard? Or are you wanting something that says, okay, it's going to get reasonably better on this, but a little bit worse on this. We don't quite know how much. It's much easier to do the latter than the former. And honestly, that's a lot of the time is the guide, because there are some things, especially when you're doing new products, you can't simulate because you don't know them yet until you've built them.
Did that also affect the turn rate for those companies where they're putting out more frequently new products? How did that affect that cycle?
Well, if you're looking at hardware development, and you're typically taking some components in the industries I've worked in are anywhere up to 3 months to deliver. Now, they buy multiple things, so it's not like 3 months per iteration, and they can do some machining in-house. But you're still looking at a multi-year cycle. So even if you can take a year out of a 3 to 5 year cycle, that's a considerable number of new products to make it out. If the products are slightly better, all the better. And if you're getting them out and making money on them, a $50,000 simulation package and on a 6-figure engineer to run it isn't so painful when you're looking at a new product out 30% faster.
Excellent. Are there other questions in the chat? I see it piling up there. Mark?
Mark's asking if you can check the chat about letting people talk.
Yeah. Yeah. Do I need? Who would like to come off?
So Ron has been putting some comments in, and I thought that with the size group, let's go ahead and go.
Yeah, I'm opening it up. So Ron, I think you can talk. Go ahead, please, Ron.
Well, thank you very much.
Oops, went back on mute.
Let's see.
Oh, hi, Lex.
Hi, Paul.
Ron, I think you can,
Come off, yeah, come off mute now.
yeah, try again. Maybe I clicked too many times. Ron, go ahead. Hold on.
I'm unmuted now.
Yes,
Yeah.
you're
All right.
unmuted now.
Okay.
All right, sorry about that.
Hey, no problem. And I was just saying that I really appreciate watching these, and NPI Speed and myself and Mark Sneeringer together in the past, in past lives, has really shown me that I could use, simulation in the right way. I mean, like Mr. Reynolds was saying, I think that the company's got to really put a lot of effort in, and they don't want to spend the money to do that. They just want the answer, and it's sort of like a push button thing, and it's almost like chicken and the egg. If the amount of data that you need to actually put into a good simulation, considering material properties and the geometry models and et cetera, really takes a lot of time, which is what you were saying. And I just wanted to agree with that.
Thanks so much, Ron. Appreciate your comments. Thanks for coming on.
Sure. I think the fireside chat idea is also a very good one.
Oh, thank you. That's good to hear.
Yeah.
Feel free to speak up anytime if you have
Okay.
questions, to raise your hand. And I think I opened up the chat for everybody, so everybody can speak now. You can unmute yourself and let us know what your thoughts are.
Great.
So with that, I'm gonna, any other comments on simulation right now? We move on to another topic. Maybe we'll work on de-risking, which is, I think Mark's got a lead on that. So I'm gonna move to that slide. Bear with me. And I'll move to that slide, and Mark will provide our overview with our partner AIM Institute. So Mark?
Yeah, so when we've talked about de-risking in the previous webinars, we divided into sort of in the front end, when you're dealing with a lot of things you don't know. It's more about making assumptions and testing those assumptions, whereas in the back end, it's more about things we do know that are potential risks, and it's mitigating those and reducing the probability that something we know is bad, probability of it happening. So the focus on the sort of the new tools or the new digitization that's available is in this early stage of the when you're sitting there and you don't know enough to say what's the probability of something going wrong. So when you attack it as what do we know, what do we don't know, what are the assumptions that we're making, and you build up your risk management that way, that's one of the tools that we've found. This Minesweeper product, for instance, that does a good job of managing that end of it. And so it's when you make that division, it starts to clarify the risk management a lot more than if you just do it one way or the other.
And just to build on what Mark said, we're actually having a de-risking webinar next Tuesday, if you would like to learn more about that. So Dan Adams, the guy who the AIM Institute and I are going to be speaking on it. So, but if you have any questions about this, about de-risking a project, you got your unknowns and so forth, and turning them into more tangible things that are proactively managed. We all know that the less we know about a project, the more variables there are, and and uncertainty, and that uncertainty turns into, often going down the wrong track for a while. So having a concerted effort to remove uncertainty in your new product design early on, as Mark said, and then throughout the project and tracking it weekly or monthly throughout the project helps keep everybody on the same page. So it's somewhat of an alignment tool also, you can call it. It ticks a lot of boxes to help the project move along. And then if there's so much risk in your project because in uncertainty, you're doing simulation models and you're not able to pin it down, it may be that, you may need to put that project on hold and then spend time on other projects, because we all have too many projects to work on. So it also helps in the prioritization of your NPI string. Any comments or questions on this tool?
I think it could actually be used to also build your simulation models in terms of assumptions, listing your assumptions and which one of those might impact the modeling effort or make it take more time or less, etc.
That's a great insight, Ron. That's really good. That's great. Thank you. Any other comments?
Yeah, for those of us who are steeped in things like FMEA, failure modes effects analysis, or project risk assessment, the sort of things of, we know this is an issue. How do we make sure it doesn't happen? This moving toward the whole thing of the assumptions and going from uncertainty to certainty is a bit of an eye-opener in terms of how to manage this stuff. Phil, remind me, there's a whole school of thought that this comes out of, and I'm blanking on the name of it right now.
Discovery-driven planning.
Discovery, yes, discovery-driven planning.
Wharton Business School.
Yeah.
Yeah, DDP. So that's a whole nother area that you could do more than a webinar's worth of discussion on.
Yeah.
DDP.
But it's the basics on which this sort of an approach is built. So
that's right. Yeah. So that's great injection. Any other comments, questions about this?
Yeah, I've kind of a question here, and maybe this will take us in a direction we don't want to go, and that's fine. But when we're dealing with risk, and it's fine when you're dealing with the engineering and you're going through all this and the risk and what could happen and what's going wrong. One thing I often find is very difficult is communication to management, especially multiple levels separated. One level you can communicate consistently with and deal with. When you start having somebody who's coming in every 2 months and they've got whatever pressures they have on them, it's very hard to get risk over. When you say, well, it's 80% okay, well, you're 80% confident, that's still 1 in 5 that it can go wrong. So when it goes wrong, they're like, but you told me this would succeed. And you're like, no. So I find management here, when you say 20% confident, they hear 0. If you say 80% confident, they're like, it's certain. And if you say 50-50, they're like, you have no idea what you're doing.
That's beautiful, Paul. What you're saying, Paul, it's exactly what this is about.
They get taught that in their MBA. That's how they're told to do this.
But that's exactly why you do this, because in this register, you have a register on every single assumption and action plan and what you did with that assumption and how you turn that uncertainty into certainty. So if it's a high risk item and it has great uncertainty and it plagues you throughout the project, like you said, and people have written it off for some reason, it's not documented, or Frank, who did it, is no longer with the company, right? So here you're going to document that in this tool, and you have a paper trail, so to speak, of exactly what the team decided, why they decided what they decided at that time. And then when management says, oh, just change this, change this curve over here to concave versus convex, whatever it is. I know that's crazy analogy, but whatever they dream of, just do it because it will sell better, right? We've already done that, and we don't have to spend a week or a month to figure it out. It's already there. So when management comes in, we're briefing them on, these are all our assumptions. You say to management, review these before you come to us with all your interesting ideas when we're already almost designed, and we're almost done with the NPI process. But what you just said is the reason for this. Does that help?
Yeah, I think in terms of the technical side, yeah, I think the other side is then the communication.
Yep.
That's an organizational issue, not a tool issue.
Well, no, but this helps the communication because this is now part of your toll gate reviews. It's part of all your weekly, monthly reviews. This is part of the way you run your NPI program. This isn't a once and done thing, as you can see here. Right. This is part of your program. This is part of the cadence.
Yeah. The risk management, tracking that with the folks who are tracking along with you, but there are times I think where, an executive will come into the process rarely. They're not in all the NPI gate reviews and stuff like that. And there, I think there's an education need on their part that I'm not sure that any tool will address, but it's more the culture of the organization and stuff that needs to be dealt with. So
if the management doesn't want to communicate and only communicate spottedly, that's a whole nother problem.
Yeah.
But,
yep.
I'm kind of interested in the Amazon approach, where it's everybody comes in and sits quietly reading the documents for 10 minutes before the meeting starts. And sometimes I'm like, well, that's ridiculous. You should all know it and be coming prepared. And other times I'm like, no, because there's always a couple of people, especially the higher ups, that aren't. So if there's anyone from Amazon, could they comment on how that works?
No.
It works very well. If you can share your document ahead, but not everybody reads it. So what they did was to say, doesn't matter whether you read it or not, first 10 minutes, first 20 minutes, we are going to read the doc. And while you read, you can put your comments on the feedback and then you post it. So you've accumulated everybody's comments quietly, and then you do the debrief. And the doc is minimum 1 page, max 6 page. Anything beyond 6 pages goes to appendix. So it puts the time box on. We can do the review or reading in 20 minutes max.
Okay, and I suppose it saves the question. Yes, I actually answer that question on page 3.
Okay.
Yeah. Okay.
And PowerPoint slides are not allowed. It's got to be Word document descriptive. So it has to be very clear.
Okay.
all right, so it's 1/4 to the hour. So I thought we'd just change topics here. The next topic here is CAD, CAM, and K. Anyone want to take that one on digitization and the change, what you've seen, and how those three have come together more integrated than in the past?
I'd love to hear Ron talk about what the evolution of this has been over the last 20 years, since that I think is his where he operates, right?
Yes, it is. I was just going to say, it has merged, but it's still it's the same issues, the same questions are coming back again and again. Like we used to call it back in the 80s, even, concurrent engineering, like, oh yeah, that's, some kind of magic pill that you take. but I mean, and then couple that with the change in computer architecture. So back in the 80s, if I had what I have today in my phone, I probably would have been you could have answered any question and done a lot of things. But even today, people are using these models. They develop the models, but they develop them in a singular fashion rather than sorry, yes, stochastic fashion. And um and so because it's hard to do that. I mean, and so today, in terms of CAE, I think people go after these hard questions and think that the simulation model can really answer it. But you really have to know your physics, even down to the almost the microscopic level sometimes. And then you pull in the whole infrastructure and computer architecture changes, what they're doing with AI,
Sure.
AI to learn what simulation data is actually telling you. And then I just, it's just exploding right now. But I mean, to think back to the 80s, it's a hard thing to do.
I always think of George Jetson there.
Yeah, exactly. I mean, the other day I saw a LinkedIn article on the flying car, and I thought, this is the Jetsons coming true.
There it is.
Yep.
Yeah. To your point, I think the explosion in artificial intelligence, and we have a few slides at the end here, but the deep learning, the pattern recognition for those handoffs between those, together with simulation, is, like you said, it's exploding now. People are trying to figure it out, how it can work. We all dream that it's going to work, but it all comes down to these handoffs, right? In the assumptions in the modeling, as you said, Ron. So
right. I mean, you're even talking about the information, the IT people have to understand that engineering computing is actually something that we should be doing. I mean, they think it's, because it's on the computer, it's in their realm only, and security and cybersecurity, it has to be accounted for. But I need cloud resources to be able to run some of these models. I mean, to run some of these models and have it be efficient so it can turn around in a day. We got to run hundreds of cores of CPU power. And even that, it's hard to convince them that that's even necessary.
Yeah, so we're still hardware constraint here.
I actually don't think it's hardware constraining. I think that's actually company culture. I spent 4 years trying to even get a large-scale cluster installed in a large company, and they spent the money on the cluster, and then it sat there for 4 years trying to deal with internal IT and their security. Of just basically, as soon as you ask anything, the answer is no, and then they're like, "What was the question?" It's like they will not do anything. But I think a lot of this, though, is talking things like AI, that is putting a lot of effort into, I actually think, avoiding trying to do everything but clean the room. It's CAD. You have your mechanical engineer do the drawing, but even with, the companies will tell you, oh, we've got auto meshers and it will just import that directly to the simulation. No, it won't.
No, it won't.
A cube, that's it. It won't. And so it needs somebody to intervene to make sure that all the little things are taken account. And then you go, that tiny little thing there? Yeah, we're just getting rid of that for the simulation. And know what you do and what you don't do, because you can't just put it all in. So
Right.
it doesn't automatically go through. And I don't see that happening for a very long time until basically the effort that needs to get everything working, that's what companies don't want to put in. So you have to, again, simplify down. And there's always roadblocks. So I think when you get to a big enough company that has the resources to do this type of thing, a lot of the time it's a big enough company that there's the resources in there that want to stop you doing it because their job is to stop you doing it. So it's an interesting mix of these things. And I think what I see is everything is separate. And you just have to have talented people willing to spend the time and get through each stage.
So culture eats strategy for breakfast, but we're saying culture eats execution for breakfast. Huh?
Absolutely. I mean, I think that the that has a major effect on the speed of what can get done, and because they want the push button answer, yes or no, to decide on a business case or not. Getting that speed down is going to be very important.
So we have just a few minutes left. I'm going to switch the topic to one more topic, if it's okay. I'm going to move over to this topic. Phil, if you could take the lead here, if you have enough time here to introduce us to this and drive some discussion, because this is pretty important.
Yeah, this is a topic that's of interest to both technologists or designers and engineers, as well as business people. The concept is the S-curve. The S-curve is a very old concept. Most systems evolve in the fashion of an S-curve. The exact shape is immaterial. It's actually debated is exactly that shape or not. But it originally comes from the theory of diffusion of innovation that is published in the 1960s. If you know calculus, you integrate it, that's the shape of that curve. The idea is that initially the systems evolve slowly, and then it ramps up very quickly, and then it reaches a maturity. So when it reaches its maturity, the perceived performance, we think that there is no more place to go. So when there is no more place to go, you basically have 4 options. The customer expectations, that's what I called it, target. If that's higher than the perceived limit, then you have these 4 options. One is tell the customer that that's just not possible, too expensive, it just can't be done, lower the customer's expectations. That's option 1. The second option is to say that the old system that we have, is there a way we can extend it and make it better? Can I take the old car, the IC engine, can I improve it with some way and extend the S-curve, even though the perceived performance ended, we did a design number 2 or the next generation, we are able to satisfy it. The third option is to say, forget that IC engine to generate energy. We're going solar. We got a new system. It has all these abilities, and it can outperform the old one. So in that case, that's the third option, new platform addressing it. There is a fourth option, and the fourth option is to actually say the new platform or the old platform are still not doing good enough, and the old platform has no more place to go. Can I modify and change the new platform? So what I discussed is very deep. In fact, you can read about all those 4 strategies in greater depth, and you can do a 1-hour seminar on all of those. But that's not the intent in this 3 minutes. So then what can you do? Where can I help me technologies to do 2, 3, or 4? And if you go to the next slide, 2 prominent approaches. One is trees, theory of inventive problem solving. Another one is biomimicry. That is, nature has solved our problem. Has nature figured out how to get to the next S-curve? So this is trees. It says 120 million patents. we've codified them and extract some principles out of them. And one of those principles is a set of evolutionary trends. We can look at the trends from patent research and predict the next stages of evolution. Here is one of those such analysis and research, 32 trends. What do they look like? Next slide. One of these trends says that especially things that are mechanical, it starts with immobile or immobile, and then it becomes jointed, then it becomes flexible, then it evolves into liquid and gas, and eventually to a field invisible. Case in point illustration, we use the shield to protect from the bullet reaching or something, protect your body. It's evolved in this shape. And the interesting is it stopped at the completely flexible Kevlar. Well, what's next? The trend based on the analysis predicts that liquid and gas might be the solution. So DuPont makes that Kevlar, they stopped it. But a Polish company looked at this and said, there is some other way to solve the problem. And they did. I think it was 2018 or something. They came up with the idea of embedding a non-Newtonian fluid along with the Kevlar. The Newtonian fluid, when a shocking stuff comes into it, it becomes rigid. It makes the Kevlar much more effective. Nobody ever imagined the next evolution in this case would be liquid and gas, or liquid turned out to be true. Well, what's the next evolution? It's the field, an invisible field. There are several fields, some electromagnetic field, can it solve it? Boeing has a patent on solving, in the wartime, projectiles coming, they repel it with the help of field. Not quite practically feasible, but it is there. What's the point? If you know the trend ahead, can I actually go ahead and do research on it? Can I get ahead of my competitors using that direction? Instead of randomly brainstorming, it helps you which direction to go. So we are able to do this with the help of digitization, analyzing 120 million patents one at a time, like Altshuler's days in the 1950s. That's no longer feasible. So today we have research done with the help of NLP and AI, where we are trying to find patterns. So that's trees. I think we're probably going to be running out of time for me to talk about biomimicry.
Yeah. So any questions, comments on this field, the S-curve, trees, any folks have experience in this and share anything, or just general questions on how this works?
So one related area to this, Phil, is that a lot of inventions get more use from their second use, or more value from their second use than their original invention. I mean, the classic on that is the transistor was invented for hearing aids, right? And then took off in radios and things like that. And there's been a number of other ones like that. Does that also show up in this sort of analysis that you're doing here?
Very much so. So Jim, if you go back to the previous slide, the S-curve, go back right there. So I only showed a Schimble curve. The second scenario changed the old platform. So transistors' perceived performance was low, but then how did transistors succeed? So while it's not good enough to put it in the radio yet, in fact, it failed. $1 billion investment story, it failed, transistor couldn't be happened. But then they said, are there situations where that transistor was good enough? Maybe the hearing aid, maybe the small pocket radio. Sony said, let's put that thing in the pocket radio. It's good enough for the kids, and they are able to walk around. There was nothing available for them that is miniature they could use. They actually found a use of it. The second way it happened was, then they said, can I extend this platform in the future? So they took the transistor, they improved it, they stretched it out and find new ways. So this is definitely part of that analysis.
Great. Well, we're coming up on the hour, and I want to thank everybody for joining us, and our speakers, Phil, Mark, and of course, Paul, for coming in. I hope you found it enjoyable. Just want to close it out with a slide that discusses our resilient digital ecosystem and how we look at how everything should be put together. We've discussed a lot about how important data is in getting disparate data and moving it into an ecosystem thought process. Paul gave us some really good insights on that. And then the second pillar is around visibility, where we look at data that's more rear view mirror. We've also discussed that. You know, the challenge we have that many of our reports are batch run and it's not real time. We did not get to talk about digital twins, prescriptive statistics, and moving up in this chain. It's another great discussion area. And the third is, of course, the hot word or phrase, artificial intelligence, that everybody talks about. We put on there targeted AI solutions because realistically, you can't really, people don't have the ecosystem to do an end-to-end AI solution today. Very, very few companies have that. It takes tremendous amount of work. So really most of the AI work that you'll hear about are expert systems and targeted AI applications. And you can look at this as somewhat of a maturity model as you move from bottom left, from data mining to auto machine learning in the upper right. It is accretive. If you try to skip certain areas here, you will sub-optimize your deployment in your company. So that's the other thought on this slide. And then we just want to share that EIG has a full component of providers who specialize in different areas. And we feel that we have this covered pretty well with our partners. Any questions or comments on this before we close it out completely? Okay. Again, thank you. We have a webinar next Tuesday on, as we mentioned, we also have one on Thursday and the following Tuesday and Wednesday. So we look forward to seeing you there. Thank you for joining us. As we close out, all our partners, thank you. Phil, Mark, any closing comments?
No, I think this this is an area where I think companies really can generate more speed in their NPI processes by doing the right and the intelligent application of digital tools.
Thank you, Mark. Phil,
Thank you.
any closing comments?
Not really. I mean, I think that next revolution in everything we do, especially in NPI, is the intersection of digitization into the NPI to make it more resilient, to make it more, agile, and to do all that evolution. So we still have long ways to go. We talk about AI and deep learning and everything, but it's still so premature.
Yeah, a lot of opportunity. And then our guest speaker, Paul, thank you so much.
You're welcome.
Closing comments?
I think I've said most of it. It's put the effort in and you get a reward, but it's not an easy return. It takes time, so you have to have something that's worth the investment.
Excellent. And I, on behalf of EIG, thanks everyone for joining and thank you for your interaction. Really appreciate it. Thank you so much and have a great week ahead.